In this video you will learn about the trigonometric ratios. For only right angle triangle you may use the trigonometric ratios to solve for missing sides or angles. As we know from the previous grade that a ratio is a comparison of two numbers. In trigonometry the comparison is between sides of a triangle. The sides of a right angle triangle are given special name: hypotenuse, opposite, and the adjacent. The hypotenuse is the longest side and is always the opposite side right angle. In this triangle, this is hypotenuse. This will always be the hypotenuse. This is 90 degree. This makes the right angle a right angle. Without it, we cannot use trigonometric ratios. Now that we agree about the hypotenuse and the right angle, there are only four things left: the other two angles and the other two sides. We will refer to the sides in terms of their proximity to the angle. In this triangle, if we look at the angle A, there is one side that is adjacent to it and the other side is opposite from it. And of course we have the hypotenuse. In this triangle, if we look at the angle B, there is one side that is adjacent to it and the other side is opposite from it. And of course we have the hypotenuse. One more thing before we learn about the trigonometric ratios. Theta is the symbol for unknown angle measurements. Theta is the 8th letter of Greek alphabet. Don't let it scare you. It's like X or Y, except for angle measurement. It's a way for us to keep our variable understandable and organized. In this slide, we will learn about the three different types of trigonometric ratios. The first one is sine. Its abbreviation is SIN, sine. Its formula is sine theta is equal to the length of opposite side over the length of hypotenuse. The second trigonometric ratio is cosine. Its abbreviation is cos, COS. Its formula is cos theta is equal to the length of adjacent side over the length of hypotenuse. The third trigonometric ratio is tangent. Its abbreviation is tan, TAN. Its formula is tan theta is equal to the length of opposite side over the length of adjacent side. To remember it, here are the acronyms for your memory aid. SOHCAHTOA. Don't forget to put this on your memory aid. In this slide, we will learn about how to find an angle from a triangle using the trigonometric ratio. To find a missing angle from a right angle triangle, we need to know two sides of the triangle. We can then choose the appropriate ratio, sine, cos, or tan, and use the calculator to identify the angle from the decimal value of the ratio. In this triangle, the length of adjacent side and the length of hypotenuse sides are given. If we want to find out the measurement of angle C, we will use a cosine ratio. And if we replace the length of adjacent side and the length of hypotenuse side, we can find out the measurement of angle C, which is 64.6 degree. In this triangle, the length of adjacent side and the length of opposite sides are given. If we want to find out the measurement of angle A, we will use a tangent ratio. If we replace the value of length of opposite side and the length of adjacent side, we can find out the measurement of angle A, which is 69.4 degree. Now let's look at the example 3. In this triangle, the length of opposite side and the length of hypotenuse sides are given. If we want to find out the measurement of angle A, we will use a sine ratio. If we replace the value of the length of opposite side and the length of hypotenuse side, we can find out the measurement of angle A, which is 56.4 degree. In right angle triangle, if the length of one side and one of the angle measurement is given, we can find out the length of all the sides using the trigonometric ratios. Let's see one example. In this triangle, the length of the hypotenuse is given, which is 7 centimeter. The measurement of angle is given, which is 30 degree. If we want to find out the length of adjacent, we can use the cosine ratio. If we replace the value of the length of the hypotenuse and the measurement of angle A, we can find out the length of adjacent side, which is 6.1 centimeter. Now let's use these trigonometric ratios to solve some problems from the textbook. Please check the link in the description box for the more information.